Alrighty, welcome all you cool cats and kittens to Introduction to Probability. I'm sure a lot of you guys have heard about probability before, but for those of you who haven't or don't really know how to put in words what it means, probability is the likelihood Likelihood's another word for chance. So the likelihood or the chance of something happening, of an event. Again, an event, like we see it right here, means just something happening. Probability is the likelihood or the chance of an event, which is just something happening. So, like I said, an event can be anything. It could be flipping heads on a coin. It could be rolling a 2 on a dice. An event is just something that happens. This means the probability of an event. We've told you all before, math people are lazy. They don't want to write out a whole lot, so they just abbreviate probability with the letter P, and whatever they're looking for is going to be on the inside of the parentheses. So for you to calculate the probability of something happening, you put the number of ways it occurs over the possible outcomes. We'll get down, we'll be doing some examples at the bottom. The complement, this is not addressed in Edmentum. We just want to make sure that you've seen it and you've heard it. A complement is the opposite of something happening. So the complement of flipping heads is flipping tails. Again, that keyword there is opposite. The opposite of flipping heads on a coin is flipping tails. To figure out the probability of a complement, this is for a probability of a complement, you'd pick the number of ways that it cannot occur over the possible outcomes. And again, we'll get to a problem like this later. A sample space is a way of showing all outcomes or all things that could happen. You can see this in a list, a table, or a tree diagram. They don't have us go into tree diagrams. I think you get into that in 8th grade, but here we'll see lists sometimes, or we might see tables. Here it says multiply the various number of options together to get the total outcomes. Again, this tree diagram, that's 8th grade. Multiplying things together to get your outcomes, that's 8th grade. Don't worry about that bottom part right there. So let's come down to this picture that we have. We have some bones, we have some tennis balls, and we have some collars. And the problem says, Mr. Snook bought the items in the picture to the right. Oh my gosh, that should say left. Miss LaRosa made a mistake. Let me change that. Picture of the left for Miss LaRosa's dog, Jacko. Find the probability for each of the objects and write it below. So the probability for these tennis balls, to figure out probability like we saw up top, it's going to be in a fraction form. The top number is the number of ways it occurs. So for this situation, it'll be the number of tennis balls over the total possible outcomes. So here we'll have the number of balls over the number of objects. And that'll be our probability. the number of balls over the number of objects. So in our picture, we see we have 1, 2, 3, 4, 5 tennis balls. So my number up top would be 5. And then below we need the number of objects. So we see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 objects. So our bottom number is going to be 12. And as always, we want to simplify our fractions if we can. Can we simplify 5 over 12? No, we can't. So that's the probability of us picking a ball. Now for the bones, we count there's 1, 2, 3, 4 bones. So again, that 4 is going to go up top because our top number is the number of bones over the number of objects. Again, we had 4 bones out of how many objects were there? 12. Can we simplify 4 over 12? Yeah, what number goes into both of them? We could divide by 2, or what other number could we divide by? 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So the probability of you grabbing a bone out of this bag of stuff would be 1/3, or 1 out of 3. Then we have the collars. So here's 1 collar, 2 collars, 3 collars. So we have 3 collars out of how many total objects? 12. Can we simplify 3 over 12? Yeah, what can we divide by? 3. And that's going to simplify to 1/4. That would be the probability of picking a collar. We're going to add a problem in here together where we can practice using the complement. So let's find a complement of picking a ball. What does complement mean again? The opposite. So I want to know the probability of not getting a ball. I want to know the probability of not getting a ball. So for our probability, it would be the number of things that are not a ball over the total number of objects. So in this problem, again, we know the total number of objects is what? 12, because it's the same. We have 12 things in there. We need to count how many things are not a ball. So we have 1, 2, 3, 4, 5, 6, 7. 7 things are not a ball out of 12 total objects. So complement, remember, that means opposite. We are not trying to do that thing. Nice job, nice job. All right, go ahead, take a break, do some stretching, get some water, get a snack. When you come back, we're going to go over the likelihood scale. Okay, so now talking about the likelihood scale. Okay, so first off, we need to know that this word likelihood means the chance of something happening. So it's like probability. This scale goes from 0 to 1. It cannot be smaller than 0. It cannot be more than 1. It's between 0 and 1. And so right in the middle we have 0.5, or 1/2. So on this likelihood scale, we use different words to express or describe the probability of something happening. So if there is a 0 chance of something happening, we call that impossible. 0%, 0 out of whatever that number is, maybe it's 0 out of 2, is impossible. It cannot happen. On the one side, we have the word certain. Sorry, that's C. It's kind of hard to see. If it is certain, that means that there is a 100% chance of it happening. So maybe it's 6 out of 6. 100%. It's going to simplify to 1. It is going to happen, no doubt about it. An example of something being impossible would be like if I flip a coin and I get a thumb. There's no thumbs on a coin. That can't happen. A certain 100% would be if I roll a dice and I get a number. All you have on dice are numbers, and so that's 100%. That is definitely going to happen. Something in this middle part, there's a few different words for it, so I'm going to write all of them out for you. So on Edmentum, they say neither likely or unlikely. I've also seen as likely as not. And that's going to be a 50% chance of it happening, or simplified, a 1 out of 2. So my probability of flipping heads on a coin would be 1 heads out of 2 total options, as likely as not. Then we have some ranges where we can see different options. So for example, if we are between 1% to 49%, we call that unlikely. Everything in that space, the chances of it happening, we call that unlikely. Here we have 51% to 99%. We call that likely. There is a good chance of that happening. So again, impossible is only this 1 point at 0. Neither likely or unlikely, as likely as not, is only this one spot there. 50%. Certain is only this one spot here at 1. But unlikely is for all of this stuff in the middle is unlikely. All of this stuff here is considered likely. They have bigger ranges. So when they ask you to describe probability, when they want you to describe probability, describe means use words. When they want you to describe probability, you need to use those words. Impossible, unlikely, neither likely or unlikely, as likely as not, likely or certain. Use those words to describe probability. Give words to talk about it. The last thing that we need to talk about with you guys up here is the difference in the types of probability. For 7th grade, we're only going to talk about 2 types of probability. This first type of probability is called experimental probability. Experimental probability is the number of times an event occurs to the total number of trials. The number of times an event occurs to the total number of trials. It's just like in science class, you're going to do an experiment. These numbers are going to be based on data. Your data is usually displayed in tables. Again, just like science class, you do an experiment, you record your observations, and that gives you data, and that's what you base your probability on. So for example, an experimental probability, an observation would be a number cube, that's another word for dice, is rolled and lands on 4. That is experimental probability, that is data. You have to do something. 3 out of 17 light switches are defective. Again, they did something, and that's how they got their numbers. So let's add that on here for a note. You have to do something. You have to do something to get experimental probability. Those numbers don't just come out of thin air. You have to do something to get experimental probability. Theoretical probability is the probability of an event happening based on all possible outcomes. It is based on what you expect. It's kind of like a hypothesis. Your theoretical probability is kind of like a hypothesis in science class. It's what you think is going to happen, what you expect or think. You don't actually do anything. This is just what you expect. Theoretical probability is what you expect. Experimental probability, you have to do something. It's what you get. So the theoretical probability of rolling a 4 is 1 out of 6. Because if I have a dice, there is 1 4 out of 6 total sides. If I have a coin, there's a 50% chance of that coin landing on tails. That's what I expect to happen. Experimental probability and theoretical probability are not always the same. Experimental and theoretical probability are not always the same. Let's write that down here too. Experimental probability and theoretical probability are not always the same. But what you will find is if you do an experiment, as the number of trials in your experimental probability increases, the experimental probability comes close to the theoretical probability. The more times you do an experiment, the closer the numbers from your experimental probability come to your theoretical probability. On one of the slides in this unit, I show you that I do an experiment, and you see that at the beginning, the experimental does not match theoretical, but the more of an experiment I do, the closer the numbers match the theoretical probability. So that is everything for our introduction to probability. I know that was a lot, so if you need to come back and watch this video, look at this sheet, please do so, and good luck with your Admentum unit.